So I'd like to show you the comparison of the Celsius and the Fahrenheit scale when we're talking about changing the state of matter, well, specifically changing the state of water. So we want to remember that there are two scales that we'll use. We'll use the Fahrenheit scale because in the United States we still use degrees Fahrenheit. And we also use the Celsius scale. Most of the scientific community uses the Celsius scale, okay, so degrees C. And you'll see the words, they're very big words. So let's look at Fahrenheit. It's a German name. It's Fahrenheit. And Celsius. So be sure that you recognize those words. This word is degrees Celsius, and that's why we do the little degree sign with a C. And this is Fahrenheit, and that's why we do the little degree sign with an F. Okay, so what you need to remember is the freezing point of water and the boiling point of water for each of these temperature scales. Okay, Celsius is quite easy. The freezing point is 0 degrees Celsius, and the boiling point is 100 degrees Celsius. Okay, that's the freezing and the boiling point of water in degrees Celsius. And in Fahrenheit, it's 32 degrees Fahrenheit for the freezing point and 212 degrees Fahrenheit for the boiling point. And what I need you to remember is the state of matter at these points, okay? So since this is the freezing point, then water is a solid, okay? So that's where we would have an ice cube or ice starting to form on the water. And alternately, at 100 degrees Celsius, that's the boiling point of water. And at this point, water is a vapor, okay? Or becoming a vapor. And what we need to know for our purposes is that in between each of these temperatures, water is a liquid, okay? So if you are posed a question with a certain type of matter being at a certain degree, freezing or solid, and then the matter is at another temperature, that it's a vapor, you need to remember that the temperature in between is the point at which that matter will be a